Hello, I'm Philip Wade. Thank you for watching these videos. This is the 9th video in the series I'm doing on CLICK PLC programming tutorial. Today's video is going to be centered around motor control, motor start-stop of a three-phase motor. First, we'll look at the first drawing that I've done, which is shown here, using it with standard relays. And then the second one will be done showing it with a PLC, and then we'll show in the program how it works. If you like these videos, please subscribe. Please ring the bell to get the newest and latest additions that I add to it, and also press the like. Thank you very much, and let's get started. The first method of motor control that we want to talk about is the standard relay contactor version, which is what I've drawn here. I'll go over the details on this. Not that everyone needs every one of these details, but there might be a few who do. So I don't want to lose anyone, so let's get started. You can see my main supply is a 230 volt AC coming in on lines A, B, and C, and the ground. They come into the first circuit breaker named a CB1. It's a 30 amp circuit breaker, and the wires coming off of that are L1, L2, and L3. They become the power supply lines for anything that's attached to this. And then you have the branch circuits coming off. The first branch is for the motor, the main conveyor motor, 5 horsepower. The second branch is for a 24 volt power supply. Let me zoom in one more time here. The dotted lines that you see here indicate that all three sections of this circuit breaker are mechanically connected and operated at exactly the same time. The same is true for MS1, motor starter 1. All three contacts of the main power are connected together, as well as the auxiliary contact. Now, when we come off on the branch number 1, the first branch, we go to the first circuit breaker on that branch, which is CB2. I've shown it as a 20 amp circuit breaker, 3-phase. And then off of that, we have one L1, one L2, and one L3. The first one indicates the branch, and the second two letters indicate which of the power leads it's coming from. So this is one L1, one L2, and one L3. And then we get to the motor starter, MS1. And the difference between a starter and a contactor is a starter has an overload built into it or connected to it, whereas a contactor is just the contacts themselves, like a powerful relay. This little curvy line here represents the thermal overload. If the current is higher than what's rated for that thermal overload on that particular leg to the motor, then it gets hot, it trips the overload, and when it trips the overload, that shuts off, opens up the contactor. We come in at 1L1, 1L2, and 1L3. We go through MS1 contacts and the thermal overload, and then we leave the control panel. This dotted line represents something leaving the control panel and going out to the motor, and this becomes 1T1, 1T2, and 1T3. And I said before, this is labeled as MTR1 for motor 1. It's the main conveyor motor. I've shown it as a 5 horsepower, 12.3 amps. Now the auxiliary contact, I've shown here that it connects to wire 106 and to wire 105. We'll see this later in the control section. Branch number 2 has circuit breaker number 3, CB3. I've shown it as a 2 amp circuit breaker. It's a 2-pole circuit breaker. And off of it, we have 2 L1 and 2 L2, and they go to a power supply. I didn't give any designation to the power supply, such as a part number or amp capacity. I was just, in general, showing that it was a power supply. That we have the two leads coming in, and we know that they are 208 volts. No, excuse me, 230 volts. We have 230 volts coming into L1 in neutral. And from the power supply, we're getting, let me zoom in just a little bit closer again. We're getting plus 24 and 0. Now the plus 24 becomes wire number 101, and the 0 becomes wire 100. Let's look over now to the control circuit side. Get up a little bit. So on the control side, you can see we have wire number 101 and wire number 100, which are coming from the 24 volt power supply. 101 being the plus 24, 100 being the 0, which is also known as common. And here you can see I'm just showing a very simple emergency stop circuit with a simple emergency stop push button, which is in a reset or closed position, and an MCR relay, a master control relay, which if it loses its power because there's an emergency stop, opens up here and kills all the power to the remaining control circuit. Now this doesn't meet the real safety requirements that you would normally require, because now you pretty much always are going to be using a safety module in addition to an MCR. Moving down a little bit further, here coming off the MCR, wire number 103 now becomes the power lead for the rest of the control circuit. So we go immediately into the stop push button, which is normally closed. Then we have a normally open start push button, and then we have the CR1, which is the control relay, which is labeled as run main conveyor. So when someone presses the start push button, we have power from 103 that comes through the stop push button, now comes through the start push button, and energizes CR1, which energizes part of the bypass loop here, and at the same time energizes the MS1 motor starter number 1, which is the starter for the main conveyor motor. Once it's energized, then the rest of the bypass here is completed. CR1 is closed, MS1 is closed. So by the time the person takes their finger off of the start button, the bypass should be complete, which would maintain CR1 energized. Now a relay and a contactor usually takes somewhere in the area of 15 to maybe 22 milliseconds to energize and close the contacts. If a person keeps their finger on the push button closed for at least 30 milliseconds, there should never be a problem with latching in the control circuit. Now here you see the motor overload, which if I zoom back up just a little bit over here, you can see over here on the left hand side the motor overload thermal units right here. When one of them becomes excessive and it trips, it actually opens up this contact, which is in series with a motor starter coil, which opens up the motor starter coil and opens this contact as well, and we lose the latch that keeps the run circuit energized. Now I've also shown a green light here, the G indicating that it's a green light, so that when the main conveyor is started, we have a green light that turns on somewhere in the vicinity of the operator to indicate that the conveyor system is running. Now that pretty much takes care of everything. Oh, let me go back and show you one more time. This MS1 is connected to wire number 106 and 105 as indicated over here. With the motor starter, you see the auxiliary contact here as 106 and 105. That's the contact that we're using here in the latch circuit. So if the motor starter trips out from an overload, then we lose the latch over here. Very simple, very straightforward. And that completes the standard relay control. So now let's move over to the PLC control diagram. Here on the left-hand side, let me zoom in a little bit so we can see the left-hand side a little bit better. Everything pretty much looks exactly the same as what we had before. The difference being that the auxiliary contact here now is connected to different wire numbers than before. It's connected to 101 and X004, which is an input. And also on the PLC power supply, I did go in and put in a part number. All right, here you can see coming off the power supply, we have the plus and minus just like we had before, excuse me, plus and 0. The plus it becomes 101 and the 0 becomes 100 or common. And you can see they're connected to the PLC. This is the PLC Automation Direct. Give me the part number here as a CLICK C0-02DR-D. That's the same one we've been using throughout all the videos. That one has discrete inputs and relay outputs, and analog inputs and outputs, in addition to RS485 communications port, serial port. So here we're still using the same simple circuit, one emergency stop push button and one master control relay. But then we changed a little bit here. This is slot 0. Now, if you remember in the earlier videos when we were showing you about the addressing, slot 0 is always on the brick PLC unit itself. It's actually the inputs and outputs that are over on this side. So here we have a common, and our common, we're tying that one back to the 0 volts, because when we have a contact coming in or an input coming in, we want the 24 volts coming in on that input to indicate that that input is now turned on. So the first input that we're using, which is X001, is from the MCR relay to let the PLC know that there is no problem with emergency stops. All emergency stops are okay. Then we have the normal open push button, just like we would have in the regular relay circuit. The normal close push button, just like we would have in the regular relay circuit. And then we also have the auxiliary contact from the main starter here as well, coming back in. And you'll see here it has wire 101 on this side and wire X004 on the other side. If we go back over here to the contact used, we can see right there that we've got it labeled as 101 and X004. Now, there's a little refreshing here. X means it's an input. The first, zoom in a little bit closer here maybe, if I can. The X means it's an input. The 0, the first 0 says it's slot 0. The next 01 indicates that it's the first input. So we have input, slot 0, input 01, and then input module or input device, slot 0, input 02 or 0.02. So you can see what we've got here. We've got all the information coming back into the PLC that we need. We have the MCR contact coming into 01, saying the emergency stops are okay. We have the normal open start push button coming into 02. We have the normally closed stop push button going into 03. And we have the auxiliary contact off the main starter, motor starter number 1, coming in to 04. Now the next, also on slot 0, is the outputs. Outputs start with a Y. We have MCR coming in. Remember, MCR is our master control relay. Back off just a little bit. MCR is our master control relay. In the event of an emergency stop, all power to the outputs are turned off. The MCR would open up. So if there's not an emergency stop, we have power to the outputs. So in that event, the PLC can turn on the motor starter and the green light to indicate that that it's running. Now these are relay outputs on this one, like I told you before. So and we're using 24 volt supply, so therefore the motor starter coil would be a 24 volt rated coil, and the lamp would be a 24 volt rated lamp, the green lamp from conveyor running. And that's really the differences right there. It looks a lot different, but in essence it's very, very similar. We have the same inputs for information to do the controls, and we have the same outputs that we had before. We're still using the 24 volt power supply. The power supply is now providing, in addition to the work it has to do over here, is providing the 30 milliamps or 50 milliamps, whatever it is, for the PLC unit itself. And that's it. Now, you might have a little bit of a question here about how this part works, and I think I need to give you a little bit more detail on that, so I'm going to open up one more drawing. Now I've opened up a third drawing, and here I'm showing the MCR coming in to C2. Now remember, the MCR is bringing in the plus 24 volts, and what's inside this output module, I told you it was a relay module, means if this contact here for output number 1 closes, we're going to put 24 volts through it to this. So that's all there is in between C2 and Y1, C2 and Y2, C2 and Y3 and Y4, like that. When you put power on this, whenever you turn one of these relays on, whatever power that you have on C2 is going to come out here. Now this could have been 120 volts, and in that case your coil for MS1 would have been 120 volts and your lamp would have been 120 volts. So that's what's on the inside of this part right here. Alright, let's go to the program. In the PLC you can see the program is very simple, only 3 rungs. The first rung is just verifying the motor safeties. The second rung is the latch circuit to control the stop-start for the main conveyor and also the lamp. And the third rung is simply end of program. I began with the address picker and I went to the inputs and I labeled the inputs MCR safeties, PB start main conveyor, PB stop main conveyor running. Then I went to the outputs and I labeled the 2 outputs that we're using, run main conveyor and main conveyor run lamp. Now the addresses on this, Y001, Y002 on the outputs, and on the inputs we are X001 through X004. And that's just exactly as what we have showing in the drawing. Very simple. Going back into the program. Now I could have probably gotten by without using this first rung. I could have just taken the input X001 and put in this position right here, the first bit in rung number 2, and then I would have only had 2 rungs in the program. But I generally like to bring in something like the safeties to a separate contact. That way if I have other safety equipment or other informations that are necessary into the safeties, I can series those together so that we would have to have all of them before we have the safeties okay. Here I'm showing an open contact for the main conveyor. The button that we've got actually showing on the drawing is normally closed for the stop. So therefore this input X3 would be turned on. So that means this would also be energized. Then the push button for the main start is normal open, so this would not be energized. So it works just exactly like what we have out front on the drawings. But let me bring up another scenario. Let's say, for example, instead of just starting a conveyor, we're starting a very large fan. And this fan blows a lot of air through a very large tunnel. Let's say this is a 100 horsepower fan. And this 100 horsepower fan blows air through a very large tunnel, and we want to make sure that the air is flowing, whether the motor's running or not. We want to make sure that the air is flowing. Or maybe it's a smaller blower for a burner unit that we have to have the air flowing before we allow the burner to turn on. In that case, maybe instead of using the X004, which is from the motor starter, we might be using a flag switch. Let's go back to the drawings. So here you can see we're using motor starter contact, the auxiliary contact off the motor starter. But what if we change that to an airflow switch? You push the button, you start the motor, the blower starts spinning up. How many seconds or how many hundredths of a second is it before the airflow is detected to the level that it has to be as a minimum to make the switch close? What if it's 2 seconds? In the program, that means this person would be holding that button for 2 seconds before we got this symbol here. Let's change this to instead of saying main conveyor running, let's say airflow detected, or just airflow. So now we're looking for airflow from the flag switch. We don't want this person to have to hold this button for that long just to make sure it works, because that brings up another problem. What if sometimes they had a problem with the airflow switch and the operator says, you know what, I'm tired of messing with this. I'm just going to stick a straight pin in here to hold the button pushed in all the time, or a small screwdriver. Now you don't have the safeties at all in here because you would always have this going straight through. because he's bypassed the bypass. There's a way we can get around that. Let's take a look. To put a little bit of safety into this type of a circuit, I've added two rungs between rung 1 and what we had was rung 2. I add in rung 2, which I take the push button start input and I change it to a rising edge, meaning it will only be seen for one scan when a button is first pressed. And that picks up this bit C2, which comes back in and latches itself on until this timer times out. Well, so the next rung is the timer. So I'm using this same bit right here, C2, start pulse, and to start the timer. And the timer runs for 2,000 milliseconds, which is 2 seconds. Once it reaches the 2 seconds, the output T1 turns on, which opens this, which removes this latch. Instead of having the push button here, the start push button like we had before, I replaced it with this C2, start pulse. So when someone presses the start button, this will close for 2 seconds. And in that 2 seconds time, you're expecting the airflow switch to be made. Now, it could be that it's one that requires a little bit longer time, maybe 3 seconds or something, but this gives you the good idea of how it would happen. Also, if someone sticks a screwdriver into the push button to maintain the push button closed, then this will still only run for 2 seconds. And at the end of 2 seconds, to start it again, say for example if the airflow switch didn't start, they would have to press the start button again to make it happen again. Because it only reads the push button on the first rung, the first scan of that pulse when it goes positive or turns on. So that takes care of it right there, just by adding a couple of rungs. But it's not that adding a couple of rungs took care of it. It's showing you a principle of a way to take care of the person to make it safe or safer. Now, there's an expression in automation: you can make any machine idiot-proof, but you can't make it operator-proof. An operator that's tired of his job, or an operator that's pushed for production or whatever, sometimes they just say, I just want to do it this way, and they try to bypass some safeties or whatever. This is a good protection here to protect someone from pressing a push button and keeping it energized all the time by trying to cheat the system. So this is an easy start-stop. It's easy to go in and convert something that's been designed for relay logic and make it into a simple PLC control that can easily be modified for other situations. I hope you enjoy this video. Thank you very much.